If you have been living on this earth long enough, you probably know that robots are taking over the mundane and repetitive work in many industries, and this will expand to more and more jobs that human beings do every day. But artists will not be affected by this, right? The majority of creative professionals like 3D artists, designers, and illustrators don't feel threatened by automation. Rather, most believe that automation will help them to be more effective and creative by freeing them from the mundane parts of their creative process. But the truth is, AI and automation are taking away artists' jobs already, especially in 3D animation. But we can't really consider it a problem now because it is not that big of a deal, but this will change in the future with more constant development of AI and machine learning. In this video, we will see a few examples of how AI and machine learning is being developed by researchers and studios in the entertainment industry in order to be able to be used in film and video games. Realistic facial animation. VFX artists and animation experts wanted to incorporate new technology in how they animate facial expressions for the main Avengers villain known as Thanos. The custom machine learning software known as Masquerade helped capture unique facial expressions of the Thanos actor Josh Brolin. The process involved placing 100 to 150 tracking dots on the actor's face. Then the data goes to the machine learning algorithm with access to a library of face scans. Masquerade, the AI program, takes the low-resolution mesh and it figures out what the high-resolution shape face would be the best solution for that. Then it gives you a solution, and then the studio will look at the result. If it didn't feel quite right, they make a little bit of tweaks here and there in modeling and animation. Then the artists just rinse and repeat the process until they compare the rendering and the actor performance side by side and find something they like. And this is a huge push forward toward realism using AI and machine learning. Generating 3D models from images. In this example, AI is able to generate simple 3D models from still images, which is impressive considering that there is different lighting on different spots of the model in the image, in addition to different camera angles, and of course this technology is still in its infancy and the models don't look that great either. The way it works is, it is able to generate 3D objects from a photorealistic space by leveraging recent advances in volumetric convolutional networks and generative adversarial nets. In addition to generating 3D models from images, the AI is able to translate and morph 3D models to similar models with different characteristics. Furthermore, it is able to morph a 3D model to another completely different 3D model, like from a car to a ship. Mode Adaptive Motion Control. This example is about real-time quadruped motion synthesis. The thing is that this technology could be really useful for video games, films, and other projects that require top-notch animation. The system can be used for creating natural animations in video games and films, and this is the first of such systematic approaches whose quality can be of practical use. It has already been implemented in video game engines such as the Unreal 3D engine. This can actually save game animators a lot of time and can be used for sure to create natural and believable animations because the AI is able to learn from motion capture data to form more smooth and realistic animations. Motion capture from videos. Recently, researchers developed a reinforcement learning-based system that can automatically capture and mimic the motions it sees in videos. Character animation is usually done using data-driven methods for decades, with motion capture being one of the most popular sources of motion data, and it is widely used in physics-based character animation. The team trained their reinforcement learning system on several datasets to estimate the pose of the character and extract the mocap data from different video clips. So you can give it video clips and the algorithm estimates the pose and the movement of the actor in each frame. In this case, the team trained their algorithm to perform more than 20 acrobatic moves like backflips, cartwheels, and even martial arts. The primary contribution of this research is a system for learning character controllers from video clips that integrates pose estimation and reinforcement learning. This will probably revolutionize the animation in the video game industry because it is going to be extremely cost effective and it is going to be super fast as well. If this technology keeps going forward, it is probably going to be used in the industry in the next 5 to 10 years. 3D character models. This example shows us how to obtain accurate 3D body models and textures from arbitrary people from a single video in which the person is moving. Based on a parametric body model, they presented a processing pipeline achieving a 3D model that fits with 0.5 centimeter accuracy, requiring only a smartphone or webcam. This method enables everyone to create their own fully animated digital double for social VR applications or a virtual try-on for online fashion shopping. This technology can be also useful for architectural visualization purposes because it needs random characters in buildings, streets, and so on. In addition to that, it can allow them to populate their scenes faster. I don't see this being used to generate high-quality characters at the same level or speed that is needed to create high-quality characters for video games and film, even though at the moment 3D scanning is a real thing in the industry. Audio-driven facial animation. This is a machine learning technique for driving 3D facial animation by audio input in real time and with low latency. The researchers trained their network with 3 to 5 minutes of high-quality animation data obtained using traditional vision-based performance capture methods. Even though the primary goal is to model the speaking style of a single actor, the model yields reasonable results even when driven with audio from other speakers with different gender, accent, or language as demonstrated in this example. This can actually have a huge market in the future, and some of the applications can go to the game development industry dialogue, low-cost localization, visual reality avatars, and many other applications as well. Image-to-image translation. This machine learning technology can actually be used practically in the future for creative aspects of video game creation and VFX production pipelines. You might pause for a moment and ask yourself, how can a machine be creative? Well, this technology can actually create actual images from drawings and sketches, which can help artists overcome the initial creative process and difficulty at the beginning of projects. And it can give artists and art directors more options to choose from in brainstorming sessions. For example, you can give it an image or something like a building, and it can create multiple variations of the same building, but it will actually look different. If you give it a sketch of a bag or a shoe, for example, it will help you create different variations in real time, which is insane by today's standards. This can actually be used by concept and 3D artists to think quickly and have more options to choose from when starting to work on their project without using too much of their precious time on coming up with ideas on concepts themselves. Facial animation from still images. This one is actually weird, creepy, and powerful at the same time. Through machine learning, it is possible to animate faces using as little as a single image. And of course, the more images and face positions the AI is given, the better it is at generating accurate and believable movements and facial expressions. Its goal is to get an input source image to mimic the motion of someone in a target output video, so that the initial picture is converted to a short video clip of a talking head. There have been lots of similar projects, so the idea is not particularly new. But what's intriguing in this example is that the system doesn't require tons of training examples and seems to work after seeing an image just once. That's why it works with painting like the Mona Lisa. This technology does not have a lot of things to do with 3D artist work, but it clearly shows what the AI and machine learning is capable of, and the fact that it is able to generate animations of facial expressions from the angle that it didn't see is just amazing. Why AI and machine learning is inevitable. One of the reasons why AI and machine learning is going to be to a certain extent replacing or even enhancing many things that 3D artists and digital artists do in general is the fact that producing high quality CGI heavy feature films is skyrocketing at cost, which is not something that the industry can keep up in the long term. So AI and machine learning have to come to place to do things that artists don't necessarily have to do, or to do other things that just take a long period of time to do and don't require a lot of creativity. Also, as we have seen, AI can be of a huge help for 3D artists, designers, and illustrators, especially at the early stages of creating projects, because it is usually where a good chunk of their time goes. So it will probably prove to be very effective and efficient for studios and artists in general. Another very important reason why software that use machine learning is going to be very important in the future is the speed at which it gets things done. Computers are infinitely faster than human beings, and if we add to this the ability to generate creative results, I believe it will save us a lot of time. So as a conclusion, machine learning does not have to be something that will replace 3D artists' jobs in the future, even though I am sure it will to a certain extent. But for the most part, it will help us create faster and at a lower cost, which allows us to jump to a whole new level of creativity and quality. I hope you found this video useful and informative. If you have something to add, please leave it in the comment section below. Also, you can check some of our previous videos. Thank you very much, and I will see you in the next one.